The NMR will be telling us
Hydrogen
the number
environment.
of hydrogen environments, right? We know this, right? And we know that the number of hydrogen environment will be showing by the number of peaks, right? Number one. We have to also know that number of hydrogen in an environment, right? So this hydrogen has got an environment of CH2, CHO, and has got 3 hydrogen in the same environment, right? On the other hand, if you see, this hydrogen has got an environment of what? CH3 on one side and CH on the other side, right? And it has got 2 hydrogen in the same environment. Lastly, this hydrogen has got an environment of what? CH2, CH3, right? This is totally different from the other two. How many hydrogen in the same environment? 1. So the ratio will be 1:2, 2:3, right? This is clear. Now move to the next
Yes,
part.
sir.
You to see that when you talk about the splitting pattern, sorry, the other examples, right? If you have got a symmetrical, right? If you have got a symmetrical molecule, right? So if you have got a symmetrical molecule, you have to know this part. If you have got a symmetrical molecule, then we have to know that it will be very important part for understand that if you have got a symmetrical molecule, then there will be same hydrogen environment in other carbons, right? Isn't it? This is symmetrical, right? Same hydrogen environment in the other carbons, right? Clear? Done this part? Do you get my point over
Yes,
here?
sir.
No, no. Now we are having the symmetrical, so it will be having this. 4 will be similar, so it will be 6:4, right? Now, move to this part where you know a very important, interesting observation that when we do the NMR, right? When we do the NMR, what we take? We take a standard. That is a trimethylsilane, right? Trimethylsilane will be used. Why? Trimethylsilane will be used because trimethylsilane will be giving you a very strong signal, right? Why strong signal? How many hydrogen environments are there in this trimethylsilane? Can you guide me?
4.
4. 4. Check. How many hydrogen environment? See, this has got an environment of what? This, isn't it?
Yeah.
And this has got an environment of what? This. Aren't these two same?
Oh, yes, sir. It's a
So,
2.
so now
2.
this hydrogen environment will be having what? This environment exactly same. See, and this hydrogen will be having an environment of what? Tell me. This. So they will be having one hydrogen environment only, right? Is it clear? Clear this part?
Oh, yeah.
One
Yes, sir.
hydrogen environment. So it has got how many hydrogen in the same environment? 12.
1.
12 hydrogen in the same
Oh,
environment.
yeah.
12 hydrogens, right? So it will be giving a very strong signal, right? Now move to this part. We know that if you see when you talk about the TMS, we have to standardize the machine, right? Get my point? We have to standardize the machine. We have to tell to the machine. We have to tell to the machine where it should compare with, right? You get my point, right? To what it will be comparing, right? This is clear to you, right? Fine.
Yes, sir.
So to know that by what you have to compare, right? So this is a very important part, right? What you have to compare with. So this is very important that if you see when you talk about when you talk about this portion, right? We have to now go to this part that if you see when you talk about when you talk about this the part of the trimethylsilane, right? We have to standardize the trimethylsilane. Is it clear to you, right? We standardize the trimethylsilane. Now, when you standardize the trimethylsilane, what we do, we can easily take out the trimethylsilane also, right? Clear to you? Fine. We can easily take out the trimethylsilane. Got it? Is it clear to you, right?
Yes, sir.
Fine. We can take out the trimethylsilane because it can be easily vaporized, right? And you always remember one thing that if you are trying to see the trimethylsilane, right? Trimethylsilane will be always coming at a little hump in the, tell me, will be coming as a little hump in the zero, right? It will be coming at 0. Did you get my point over here, right? How to do this? Are you okay?
Yes. Yeah.
Coming as a small hump. I'm showing to you this. See, it'll be coming as a small hump like this. This, can you see this? Small hump like this, right? Now, we have to remember a very important part that this is a very important observation you have to do. The HL question will be coming from here. That if you see, whenever we are having a C double bond, right? This part is very crucial. Whenever we are having a C double bond, this will be influencing the hydrogen environment next to it in a similar way, right? Splitting will be coming. Which particular chemical shift will be there? Around 2.1 to 2.7, right? no matter where they are. But it should be just how they are, no matter how they are, the carbon hydrogen, how they are. But they will be have to be right next to the C double bond. Is it clear to you? You get my point, right?
Yeah.
So if you have got a CH2 group of CH over here, see, next to the CO, 2.2. If you're having a CH group, on the other side is having CH3, and the other side is having CO, it will be influenced at 2.7, 2.1. Is it clear to you? Get my point over here? Fine. This hydrogen will be influenced by what? 2.1. Do you get my point? This hydrogen will be influenced at 2.6. Is it clear? Understood?
Yeah.
Clear? This hydrogen will be influenced what? 2.1. Is it clear? Understood this part? Any question, please tell me. Done?
Done, sir.
If you have got a hydrogen environment next to a C double bond, it will be 2.1 to 2.7. This you have to memorize, right? For the HL part, right? Now, we are now going to the part, we now have to now understand that whenever we are seeing any functional group, right? Any functional group which is next to the CH group, it will be influencing. How? If we have got a CH3 group, right? Always and always the chemical shift will be around 0.9 to 1.7. Okay, this part is clear? Fine. It will be
Yes, sir.
having a chemical shift of what? Tell me. 0.9 to 1.7. This is clear to you? Fine. Is it okay? Fine.
Yes,
Fine.
sir.
It will be 0.9 to 1.7, right? If you have got a ester, now this part is very crucial, right? These two should be one. This, please open your data booklet if you have got the printout version, right? Ester will be tested, right? You told me that esters, right? You asked me. Ester will be tested,
Yes,
but
sir.
you have to know the trick. Now, can you tell me that why does the chemical shift occurs? Why does they will be having a different hydrogen environment? What is the reason? If you know that hydrogen's nucleus, right, also spin on its orbit, right? Clear? Understood? Spins on its orbit. The amount of the spins will be getting influenced by the group next to it. Is it clear to you, right? Did you get my point? How
Yeah.
does the NMR signals? We give the NMR, right? We get the NMR because hydrogen nucleus spins on its orbit. Now the spin will be influenced by the group next to it. Isn't it clear to you? See, see, if you have got a ester, right? Can you see this important part? If you have got a ester, the ester can have two kinds of hydrogen environment. Understood this part? Is this hydrogen environment and this hydrogen environment same? No.
No.
Why? Because this is next to the C double bond, right? Isn't it? And what trick did I tell you just now? If you're having a CH group next to the C double bond, it will be having what? 2.1 to 2.7, right? Always, right? Clear to you, right? Did you get my point over here? It will be always influenced by that factor, right? Always, huh? See, it's coming around. See, understood this part. Here, can you see this, right? Okay,
Yes, sir.
done this part. Now, if you have got this hydrogen next to the COC bond, it will be having a chemical shift of what? 3.7 to 4.8. This you have to memorize, right? Clear? Done this part? Okay.
Yeah. Yes, sir.
Are you okay with this? It will be having a chemical shift of C. This you memorize, right, Gaya? Sorry, Biva, I know that it is there in the data booklet, but don't worry. Memorize it, right? Right?
Yes,
You
sir.
can easily catch. You can easily catch that if the molecular, if the molecular formula is given O2 somewhere, right? O2. That means that it can be a carboxylic acid or it can be a ester, right? Isn't it? Fine. Get my point over here? Now, second part. If you see that when you talk, there's a halogen, right? This is a very important, right? If you're having a halogen, the chemical sheet will be 3.2 to 4.4, right? This is in the data booklet also. Now, if you see, when we see this part you memorize, right? If you have got an aldehyde, right? If you got an aldehyde, understood? See, this is a C double bond O, but the H is connected to the C double bond O. So this won't follow the 2.1 to 2.7. Is it clear? This hydrogen.
Yeah. Yes,
Understood
sir.
that? This is clear to you. C
Yeah.
double bond influence will be where? Where the carbon is connected next, right? With the hydrogen. Is it clear? There it will be influenced what? 2.1 to 2.7, right? If the hydrogen is directly connected to the C double bond O, aldehyde, this you memorize. It will be around 10. Got it?
Yeah.
Done?
Yes, sir.
Now, if you have got the hydrogen not connected with the carbon over here, right? In the C double bond, connected with the bridging oxygen, right? In a carboxylic acid, it will be 9 to 13, right? Done this part?
Yeah. Yes, sir.
This part you have to memorize, right? This part. Are you okay with this, right? Fine.
Yeah.
Now come to the part, we know that if we see, when we talk about the low resolution spectrum and a high resolution spectrum, right? How do we analyze this part? Low radiation and high radiation. We analyze the low radiation and high radiation part spectrum by this way. That if you see how many hydrogen environment are there, tell me. 2. What is the ratio? Please tell me. 1:2. Right? Clear? In the low
Yes, sir.
radiation, understood this part, we are getting this, right?
Yeah.
Low radiation spectrum, we are getting 1:2 ratio. See? 1:2. Now, Biva, always remember that from this now you can also understand that which is the functional group next to that hydrogen, right? We can get to idea by the data booklet, right? We just discussed, right? Now, over here, now listen to this. Now, hear this. If you are given the compound, now listen to this, Biva. If you are given the compound and asked to draw the graph, right? Understood? Asked to draw the graph, then you have to follow this principle that if you are seeing this is a hydrogen, it will be influencing the next hydrogen that peak into what? Splitting into what? Tell me. N+1 peak, right? Is it clear? Understood?
Yes,
If you
sir.
are given
Yeah.
the molecule and asked to draw the graph, understood? You have to
Yeah.
follow N+1 principle. There are 2 hydrogens over here. Got it?
Mm-hmm.
There are 2 hydrogens over here. This will be splitting this peak into what? This peak into what? Tell me. N+1. How many peaks? Tell me.
A doublet, 2.
Wait, why? 2 hydrogens are there. So N is equal to 2, right? Triplet.
But sir, I thought you meant the environment that's
No,
next to
no,
it.
environment we have completed, right? We completed. How many environments are there? 2. 2 hydrogen environment. And how many environment? 1.
Yes,
So it
sir.
will be 1:2. We get this low resolution one, right? Now, if you analyze the H-NMR by the high resolution spectrum, NMR high resolution NMR spectrum, it will
Mm-hmm.
be this peak will be divided into splitting into different peaks, right? 3, 2, 4.
Oh, okay, sir.
Did you get my
Yeah.
point over here?
Yeah.
Now, can we predict that how much will it splitting? Now, did you understand this thing? If you get the molecule and you're asked to draw the graph, right? Was it clear? If you
Mm-hmm.
have got the molecule and asked to draw the graph, got it? How to draw the graph? One hydrogen will be splitting. One hydrogen is there. It will be splitting the next carbon's peak into how many peaks? Tell me.
N
N
plus
plus
1.
1. That is 2. Can you see this?
Yes.
Okay.
Yes, sir.
Now, if you have got 2 hydrogens over here, right? That will be splitting the next carbon hydrogen into how many peaks? N plus 1. That is how much? Please tell me.
3.
3. Done this part?
Yes. Yes, sir.
Okay. Understood this part?
Yeah.
So this is a very important portion we have to master, right? Now listen to this. If you have not given the molecule, right? Viva, are you okay? If you are not given
Yes,
the
sir.
molecule and you have given the graph, right? Graph. The opposite way you have to go means you have to go by n-1, right? This one. Opposite way you have to go, right? If you have got 2 doublet, what does it mean? The next, this hydrogen is having doublet. What will be the next carbon be? Tell me. Just 1 minute. Viva, if you have got a doublet, please tell me. It will be
Oh,
splitting. Tell me, it will be splitting into doublet. So the next carbon hydrogen will be having how many hydrogens? N-1. So doublet means 2 minus 1. There will be 1 hydrogen. Is it clear to
1.
you? Understood this part? Clear?
Yes. Yes, sir.
Now, if you're given the graph triplet, this is triplet. Now the next carbon will be having how many hydrogens? Please tell me.
Um,
N minus
3
1.
minus
N
2.
minus 1. That is 2. Is it clear? There will be 2 hydrogens. Is it clear to you now?
Yeah. Yes, sir.
Understood? This part is clear. Fine. So
Yes.
depending
Yes, sir.
upon the amount, depending upon the amount of the splitting, we can go and find out the approximate. We can predict the number of hydrogen environments, right? Done this part?
Yeah.
Okay.
Yes,
Both
sir.
ways I told you, right? If you got the molecule, we can draw the graph by n+1. If we got the graph and not the molecule, we can find out the next carbon hydrogen by n-1 principle. Done
Yes,
this
sir.
part? Now
Yeah.
we know that. Can you see an interesting observation? Doublet is almost 1:1, right? Size, right? See, equal size. Triplet is having what? Can you see this? Triplet is having something like 1:2:1, right? Can you see this? This height, can you see this? Why? Do we have a shortcut? Yes. We draw the Pascal triangle, right? Clear? Are you okay with this? Huh?
Yes, sir.
Pascal triangle we draw, right? What
Mm-hmm.
we draw? We draw Pascal triangle. 1, then 1, 1. Triplet is 1, 2, 1. Understood? Quadrat is 1, 3, 3, 1. Isn't it? So if
Yes,
you're
sir.
having a squat trade, see, it'll be 1:2, tell me. 3:2,
3:3:1.
3:1. Understood? Clear? What is there?
Yeah.
Got it? Now, if
Yes.
you have got a triplet, right? If you got a triplet, it will be 1:2:1. Is it clear to you now? Right?
Yeah.
1:2:1. Done? Clear?
Yeah. Yes,
Now
sir.
let's do a question quickly. See. Now, you have to see that this part is very important. Rules for spin coupling, right? Protons on the same atom, right, do not split each other, right? Isn't it? Got my point? Now, splitting generally occurs with protons on adjacent atom, right? Clear? Get my point? Understood this
Mm-hmm.
part, right? You get my point, right? So if you have got a C double bond O, will this hydrogen bit get splitted? Because we have to have a adjacent carbon with hydrogen. Clear to you?
Oh, okay, sir.
This is
Yeah.
clear to you? This trick is clear? This hydrogen will be splitting this, right? But if you have this C double bond O, this won't split. This will be having a singlet, right? Clear? Understood?
Yes, sir. Yeah.
Are you okay with this? This concept is clear? Fine.
Yeah.
This is very crucial. Protons attached to oxygen atoms, right, do not show or cause splitting, right? Clear? Understood this part? Fine.
Yes, sir.
Suppose we are
Yeah.
having this. Suppose we're having this. Will this hydrogen split this?
No.
No.
y-
It should be
No.
always attached to carbon, right? Clear? We
Yeah.
saw that also. That caused that. See? Aldehyde, see? Although it is connected to the C double bond O, it does not come under 2.1 to 2.7. Why? Because this is connected to the C double bond directly, right? Isn't it? Get my point?
Yeah.
So over here, what happens? If we have got this won't split, right? This won't split this. Or if you have got this won't be splitted by this, right? Clear? Fine?
Yes, sir.
Fine?
Yeah.
Now see, now you'll be getting the integrated trace, right? Now what is the integrated trace? You know this part. If you see, whenever we are talking about the integrated trace, what is the integrated trace? This is very important. Now, if you see, when we are seeing this ratio can be done by a scale, right? If you understood, you can done by a scale. Okay, 1:3, right? We can see. But instead of these peaks, you might get integrated trace like this. Got it? Understood this part?
Yes, sir.
Got it? You can get integrated trace like this, right? Understood this part? So this is what? 1:, tell me, 3.
3.
Understood? You'll be getting integrated trace like this, right? Also, to back up, right? Fine. Now see the worked example which is there. In the worked example which is there, see how to do the worked example. See, they're telling you that NMR spectrum for the compound with the molecular formula CH4H8O. Is it clear? Done this part? Clear? Fine. Okay.
Yeah.
So
Yes.
does it contain a carboxylic acid? O1, see? Will it contain a carboxylic acid? Huh?
No.
This is carbon. No. Will it contain an ester? No.
No.
Because C double bond O, there is O2 should be there. O2. Is it clear to you, right? This part is clear. We can catch.
Yeah. Yes, sir. Yeah.
We can catch. Then we can also put in the formula, right? CnH2n plus 1, CnH2 plus 1 O, OH, right? This will be the general formula of alcohol, right? Clear? Understood this part? Suppose
Yeah.
C2H5OH, right? See? Did you get my point? What I'm trying to say? A general formula you have to mention also. Alcohol will be having a general formula CnH2n plus 1 OH, right? Done this part?
Mm-hmm.
Do you get my point? So did you understand this part, right? Is this alcohol?
Mm, No.
No. Good. Understood this part?
Yes,
Clear?
sir.
This part is clear? It's not an alcohol, right? Because alcohol will be having CnH2n plus 2O. You can write this also, right? It is not an alcohol. See how I'm eliminating, right? See? Clear? Got it? This
Yeah.
we get you. Now we have to now zone down to this chemical shift, right? Clear? Understood? Now I told you to memorize an important fact. If you're having a chemical shift of 0.9 to 1, what is this for? It's for a CH3 group, right? Remember, huh? Clear?
Yes, sir. Yeah.
If there's a chemical shift of 1.9 to 1, what is this for? Tell me. CH3 group,
CH3.
right? Just memorize those, huh? Which I have circled to you, right? Go to the videos, memorize those circle, right? Is it clear? Viva?
Yes,
Done
sir.
this part? So now we're getting an idea, right? We're getting a chemical shift of 2, right? See? Where there is no splitting. Can you see this? Understood?
E-
Are you
Sorry,
okay?
sir. Could you repeat that one more time?
Yeah, we are getting a chemical shift where 2, around
2.
2.1, right?
E.
2.1. No,
Yeah.
is it clear to you? And
Yes, sir.
is there any splitting? First tell me.
No, there's not.
Okay, now tell me one thing, that if you have got if you have got a chemical shift of 2.1 to 2.7, what you can guess? Tell me. I told you that trick.
C
That
double bond O.
the CH group is next to the C double bond O. Understood? Got
Yeah.
it?
Yes, sir. Yeah.
And that will be telling us the chemical shift is here, right? Clear? Done?
Yes, sir.
Now we have got
Mhm.
a quadrate over here. Can you see this? Quadrate 4, right? Understood? Hello? Are
Yes.
you
Yes,
clear?
sir. Yeah.
We got a quadrate. What does it mean? That
Is
that quadrate means what? Quadrate means that it will be having next carbon hydrogen will be having how many hydrogens?
3.
N minus 1, 3. You note down all these details, right? Clear? We have got a triplet over here at 1, right? Isn't it? Got it? What does it mean?
Mm-hmm.
The next carbon hydrogen will be having how many hydrogens?
2.
2. Means it will be inside this, something like this, right? Some bond like this, right? Clear? Okay, next carbon, right?
Yes,
Clear?
sir.
Are you okay? What all can we pluck out, actually derive out? Okay?
Yes, sir.
Information says clear to you? Getting
Yeah.
a quadrate means you're having a NCH3 group over here. We can tell over here, right? Clear? Got it from this?
Mm-hmm.
Next carbon will be having 3 hydrogens, right? Clear? Means what? How? Where it will be having 3 hydrogens? Please tell me. The NCH2 group, right? Are you okay?
Yeah. Yeah.
This is clear to you, right? Fine. You get my point over here? How to do it? Now, from this integrated test, right, we can find out the ratio easily, right? By a scale, right? Are you okay? This part is clear? So we write all the datas over here. Can you see this? We write all the datas, right? There's a chemical shift of 1.3. Understood? Now, can you put a scale over here? Integrated test. Can you put a scale? Huh? Can you help me? It's a scale. See if you put this is. See, you see this. So this will what? If you put the ratio, it will be 2:3:3, right? Clear? Got it?
So,
Integrated test. The integrated test. This integrated test, right? Like this. I told you, no. You'll be getting integrated test also. Not that the peak, the low resolution peaks will not be given over here. This is a high resolution peak. Tell me. Stop me. Stop me.
yes, sir.
This worked example is very important. What we do? We take the first measure the vertical heights of the steps of the integration test, right? 1 centimeter, 1.5 centimeter, 1.5 centimeter, right? Clear? Now, what we do in empirical formula, can you recall? Isn't it? We have to find the
Yeah.
ratio. How to
Yes,
find the
sir.
ratio? Tell me of in the empirical formula. When we get 1, 1.5, 2.5, what we did? We multiplied by 2. Got it?
Yes,
Okay.
sir. But sir, I
This
thought
this
first we
kind
need
of
to divide by the smallest.
but the smallest, but didn't I tell you the empirical formula? If it's coming 1.5, 1, 2.5, do we divide? We don't divide. We have to multiply it immediately, right? Clear? Do you get my
Yes, sir.
point?
Yeah.
Wait, hang on. Can you divide it by smallest? What comes? Tell me. 1, then please
1
divide it. You will be going round and round and round, right? Is it clear? We will go
1.67.
1.67. See, everything got messed up. And this 2.5 divided by 1.5 gives you how much?
Oh, sorry. So 2.5 divided by 1.5 was 1.67.
And 1 divided by 1.5?
Um, zero. Oh, it's 0.67.
So did you get my point? You go round and round and round. So what did I tell you for empirical formula? If you got a formula like this, right, what we do? We multiply it by 2. Easy. You
Yes,
get my
sir.
point? We first measure the vertical heights of the steps of the integration test, right? This part. And after that, what we do? We multiply by 2, right? So this gives the
Yes, sir.
ratio. Do you get my point over here, right?
Yeah.
Fine. Any question, please tell me. What we are getting over here? We are getting the chemical shift 1.1 and we are getting a triplet also. Isn't it clear to you? 2.1 singlet. Is it clear?
Yeah.
Okay, so this will be the particular data we'll be getting, right?
Yeah.
Fine. Now can we see that if you're getting a quadrate, right? If you're getting a quadrate, right? So number of protons in the adjacent carbon atom I taught you is what? N minus 1, 3.
2.
If you get a singlet, the number of protons in the adjacent carbon will be 0. Means it will be a C double bond though. It will be there. We are sure about this. Clear? See, because 2.1 is coming. See? Got it?
Yes,
Now,
sir.
what are you having? Triplet means what? Number of hydrogens in the adjacent will be 2. Clear?
Yeah.
Is it clear to you? Now we know that the peaks at 2.4, right? If it's coming 2.4 and this 1.1, right? If it's coming, are caused by an ethyl group, the signal due to two hydrogens splitting this, right? Now see, now we are seeing that uh, see just see now ISD is not there, right? ISD is not there. Now see, what is the data we get? Tell me. We get C4H8O, right? Isn't it clear? We get this per
Yeah.
data C4H8O. Understood? C4H8O1, right? Okay, this is clear. Now
Yes,
we
sir.
are getting what? There will be a CH2 group which is there, right? We know. Hmm. There'll be a there'll be a CH group next to a carbonyl group. Is it clear? Fine. Okay, this
Yeah.
is clear to you, right? So we write like this. So this 1.1 is due to the CH group where I can move here. Okay, wait. This is 1.1 and this is number of hydrogen environment is 3. Fine. Now this is a triplet, means that the next carbon will be having 2 hydrogens, right? Clear? So
Yes,
can we
sir.
write like this? Isn't it? Next carbon will be having how many hydrogens? Tell me.
2.
2. So it will be always like this. Clear? We draw like
Yeah.
this. Now see this 2.1, right? 2.1 means it is next to what? It is next to a C double bond, we know it, right? Got it?
Yeah.
Understood this part? So C double bond. Anything, please tell me. Now, next is that we are getting what? We are getting 2.4, and this is number of hydrogen environment is 2.
But sir,
This is this, right? This is this, right? This is this.
yeah.
Hmm.
Okay,
This
so
is
yeah.
this. Right? 2.4, and it will be what? It will be quadrate, right? Quadrate. So the adjacent will be 3, right? Isn't it? Adjacent is 3. Got it? Now see, finally we are coming down to this part, right? Over here, we get this singlet 2.2. So it will be next next protons will be adjacent will be 0, right? Fine.
Yeah. Yes, sir.
Is it clear? So just to make sure that you expose yourself to more type of questions, that will be better, right? This was one, right? So just brainstorm, right? Just brainstorm, right? That will be better. Just go through this part. Huh? Can you go to this part? I'm just coming back, right? You also take a break. Huh? Thank you so much. I'm just coming back. Thank you. Thank you so much. Thank you.
Yeah.
Practice, I'm telling you. Huh? Just practice all the combinations. That will be giving a hint, right? See, they're saying what the peaks at 2.4 and 1.1 are caused by an ethyl group, right? So you're having this as a triplet, this group. Now see, I'm just going backwards, right? I'm going backwards. Now if you see that, whenever as a final check, we should try to match up with the chemical shape of the protons and the values given in table 11.1, right? Isn't it? So if we have got 2.1, right? 2.1 singlet, right? That will be next to what? That will be next to, and also you're getting number of adjacent hydrogen is 0. See, so that will be, we are definite that this side, this will be there, this will be there, this will be there as a CH3 group. Is it clear to you, right? Got my point?
Yes, sir.
This will be a singlet, right? Will be a singlet. Means what? This will
It's
be
next to the C double bond O.
It's next C double bond O. Understood that thing? How to do it? The
Yes,
singlet?
sir.
Fine. And we know that 1.1, we are sure that 1.1, we are sure that this is a methyl group, right? Fine. And how many hydrogens the next? 2.
2.
Is it clear how to do it?
Yes, sir.
Understood. See, we draw like this. We draw blank like this, right? Then see, this is triplet. And you are having number of hydrogens. The next carbon is how much? 2. So this is 2. So we are very well sure that this is the carbon group. Okay.
Yes, sir.
This is clear to you? Understood this part? Now what does this means? 2.1. That means that it is next to a C double bond. And second, it does not have any hydrogen next, right? So we're very sure that this is the particular person, right? Because this does not have any hydrogen next, right? So this is this, right? Got
yes,
it?
Sir.
And we're getting what? We're getting over here quartet. Means the next hydrogen will be 3. So this is the person. Next hydrogen is 3. Understood?
Yes, sir.
Do you get my point? How to do it?
Yeah.
So this part you have to handle like this. See, there's another example over here where you're having this, right? So this is, see, O2. What does O2 means? Tell me. What does O2 means?
Carboxylic acid.
Carboxylic acid or ester.
Yeah.
Done. Now, carboxylic acid, if you had, you'll be coming where? 9.7 to 11, right? You'll be having the chemical shift of this, right? This hydrogen. Isn't it? Is it coming? 9.7 to 11?
No.
No, so carboxylic acid is done, not there. Done? Understood how to do it?
Yeah.
Carboxylic acid not there. So this is the chart now you memorize. I'm telling you, it is there in your data booklet. Agreed. I'm agreeing. There is a data booklet, right? But can't we memorize, right? See, aldehyde you memorize, carboxylic acid you memorize, right? Clear? And this you memorize, right? This ester, right? This. Okay.
Yes, sir.
This will be now needed, right? This will be now needed, right? Got it? Now can you tell me that if you have got a O2, right? We know that it is a ester ultimately because there is no 9.7 to 13, right? We discard it, right? Now we take a scale. Now we take a scale. And what we're getting? Tell me. We can write down like this. We can write this is 4.1 coming. This is 2. This is 1.3. Understood? And what's the ratio coming? Okay, wait. Where's the ratio coming? Yeah. If you see the ratio is 2 is to 3 is to 3, right? Same thing, right? 1 is to 1.5 is to 1.5, right? So multiply by 2, we get what? 2 is to 3 is to 3, right? Now this is a quartet. Understood? Are you getting me how to do it?
Yes, sir.
This is a singlet and this is a triplet, right? So the next hydrogen in carbons is how much? Tell me. Please tell me. 3, 0,
and 2.
And we know that the molecular formula is what? C4H8O2, right? Right? Understood this part?
Yes, sir.
So can we quickly do the combinations? Can you quickly go into combinations? See, this tells you what? Tell me, what does this tells you?
It's
Tell me, 0 means what? This is next to
it's
what?
next to the
C double
C
bond
double
O.
bond O.
And is the end of the carbon chain. Is it clear? Understood? We draw this quickly. End of the carbon chain. Understood this part, right? Got it?
Oh yeah, yes sir. Yeah.
But we also know that this can be also like this also, right? Are you okay? This is clear? Clear to you? This is clear? Hmm?
Y-
Are you okay
yes
with
sir.
this can
Yeah.
be the option? This can be the option?
Yeah.
Done this part? You get my point over
Yeah.
here? How to
Yes
do
sir.
this? Now, next part is what? Next part, see. We got all the data, right? Now, here is the trick always. We get two options, this and this. Is it clear? Because it is C4H8O2. Are you okay? This is fine?
Yeah. Yes sir.
Now, the trick comes over here, right? See? Now, if you see that, whenever we are having, a particular, suppose, so there are two possibilities, right? If you consider singlets, right? Singlets is what? Singlet will be this. Singlet will be this also, right? Agreed? Fine. Are you
Yeah.
okay this? Now, can you tell me that this gives you important information, right? The singlet is coming where? Tell me. At 2, right? Is it clear?
Yeah.
Now, can you tell me that if you're having the singlet over here, how much will the chemical shift be? Just 1 minute. Before. Just Biva, can you take a break of 2 minutes? Just 1 minute. The boards. If you have got a particular part next to the bridging oxygen, what will the chemical shift be? Tell me.
3.7 to 4.8.
3.4, right? So we are seeing that this will also be a singlet option. This will be also a singlet. Why? There's no carbon connected, right? Is it clear? No hydrogen
Yes sir.
connected to the carbon, right? Clear? So this
Yeah.
can be option, this can be option. Now singlet is coming where? Tell me. 2.
At 2.
So this is not the option we know. Understood this part?
Yes sir.
Got it what I'm saying to you? Are you okay with this, right?
Yeah.
Fine.
Yes sir.
Then we have to match it, right? Then we match it, right? We can either have this, then we have to match it, right? So see, we get the option over here. Understood? Now let's see. This is done. This is done. Now you're getting 1.3. Understood? 1.3. And we are very sure 1.31 what? Tell me. 1.9 to 1 around is how much? It's a CH2 group, right?
CH2.
CH2 group, right? Number of hydrogen in the same environment, see 3. Now this will be causing a triplet, and that means what? The next carbon will be having 2. Is
CH2.
it clear to you?
Yes
And we
sir.
can. This is done. Now see, let's check this. We are having around 4.1. Isn't it clear to you? Huh? Now this you tell me. If you're having a hydrogen next to the COO bond of ester, where will the chemical shift be? Tell me. If you're having a carbon with a hydrogen next to us bridging oxygen, where will the chemical shift be? Tell me.
Between 3.7 and
3.7, 4.8. This matches over here.
4.8.
Can you understand this thing? How to catch?
Yeah.
You
Yes
get my
sir.
point? Now we absolutely clear.
Yes.
How to do
Yes.
this part? So is it clear? So this is the way we do, right? Just to help me a thing. Do some. Have you got any past paper questions? Have you
Um.
come across a past paper question of?
Yes sir. There was one that I took a picture on my phone.
Can you do
I'll
one
send
thing?
it now.
Can you just cut paste the question and the answer key in the in that what do you call it? In that group? Can you update it? Right? Fine.
Yes sir. But
Okay.
now that we did this,
Question. This is a question we're having. Now this question, what we're doing, we are seeing that we have to take a scale, right? We take a scale, right? Take a scale over here, right? Is it clear? If you take a scale, it will be
yes sir.
what? 1 is to 1.5 is to 1.5. So that is what? 2 is to 3 is to 3, right? Understood this part, right? Getting point. See over here, how many hydrogen environment you have? 3 hydrogen environment. And what is the ratio? Tell me. 2:3:3, right? Understood? And we know that, see, this is a singlet. Can you see this? Right? Understood this part? This is singlet. So, how can you do it? A propanal. If it is a propanal, where will be the that shift be? Tell me. 9 to 10, right? Is it coming? Propanal is
Mm,
aldehyde. Is it coming in that shift?
mm.
Huh?
No.
No. So this is not. Butanoic acid is there. First, tell me. If you're having a oic acid, where will the chemical shift be? Tell me. Tell me.
9 to 13.
9 to 13. Is it clear? Is it coming?
No.
So this is gone. Understood. Are you okay?
Yes, sir.
Now, if you have got a propane, right? If you got a propane is this. What will be the chemical shift? Tell me. Sorry, how many environments will be having? Tell me.
2?
2. What is the ratio? 6:2. Is 2 environments coming?
No.
So this is gone. Can you understand? If you
Okay.
cannot do, you can
Yeah.
do by what? By
Elimination.
that elimination round, right?
Yeah.
And finally, yes, ethanoate is there. See, you're getting this chemical shift. See, 3.7 to 4.8. See, understood? Get my point over here.
Yes, sir.
Are you okay with this, right? So
Yeah.
ethyl ethanoate. This is ethyl, and ethanoate is this. Ethyl ethanoate. Got it? Is it
So
clear?
isn't
Ethyl ethanoate, right?
yes, sir.
Tell me.
No,
2 is to
it's
3
okay.
to
Sorry.
3,
It's fine. Yeah.
isn't it?
Yeah.
2 is to 3 is to 3. Done from this?
Yeah. Done. Yeah.
And over
Thanks,
here,
sir.
see, we are getting this hydrogen will be coming where? This hydrogen will be coming
The singlet.
in a singlet. Understood? And where the chemical should be?
Yes.
You'd work out this, huh? You'd show me this, right? Example, right? Singlet, and it will be coming over here. This is clear. Is it clear to you?
Yes, sir.
Ethyl ethanoate is clear to you. Now this will be what? This will be 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 coming around what? Around 1 point something this. Isn't it? And this, there are 2 hydrogens. So next week we'll be split into how many peaks? Tell me. 10 plus 1, that is 2 plus 1, that is 3. Is it
4.
clear to you? Triplet. Understood this part, right?
But sir, wouldn't it be?
Now this
Oh
will be
no.
what? This
Yeah.
will be
Sorry,
splitting into
sir.
what? This will be splitting into n plus 1.
Yeah.
But quadrat. Understood? Is it clear to you? This will be the singlet. Sorry, my bad. This will be a singlet.
No,
My
I'm
bad. Huh?
not
Sorry.
understanding. Oh, okay. Okay.
This
No,
will be
that.
the singlet, right? This.
Okay.
Now clear? Are you okay?
Yes, sir.
Can you work out this and show it to me like that? Can you do this? Like that? Chart? Chart as this? Is it clear?
Yeah. Yes, sir.
Show me by the chart, right? This part, right? Okay.
So do I do it now or later?
Do it
And then I'll
later
send it.
and send it to me. Huh?
Okay.
And I have to
Yes, sir.
screen share also, right?